We have a problem looking for the cross slope at a couple of points on a spiraled horizontal curve. A lot of givens here, so I'm going to actually show these givens on a diagram and talk through them there. Some of these are unneeded, so it's important that we lay out what we have and use what we're given to find the values that we want. And specifically, we're asked for the cross slope at station 50 and station 58. So it's important, in my opinion, to start with a diagram and add to it as we go. Again, we want to look at this profile view, so we see the center line elevation being flat, and what we're looking for is those cross slopes of the inside lane and the outside lane at a couple of points here. So adding in some of the values here, we start with our TS point, station 44, plus 02.77. We're given a super elevation runoff, which is that spiral length of 275 feet, which takes us to our SC point of 46 plus 77.77. We're told that we have the circular curve portion of this is 855 feet, which will take us to our CS point of 55 plus 32.77. And then it's a symmetrical spiraled curve, so our super elevation runoff on the other side is equal to the first one of 275 feet, which gives us an ST point of 58 plus 07.77. We're also told that our design super elevation in this case is 6%, so we can add that down at points D and E. And our tangent runout is 92 feet, so we can add that into our diagram as well. We're at first point is station 50. We know it's between our SC and CS just based on the stationing. So this is a relatively straightforward question. We're looking for that cross slope. Both the inside and outside lanes will be sloped at our design super elevation of 6%. So the answer for the first part, 6% cross slope across the full pavement at station 50. So draw a box around that one. Our next one, we're looking for station 58, and this is in between our design super elevation and adverse crown removed. And it's really close to that adverse crown removed. So at this point, we know we're within that tangent runout, and so our inside edge of pavement is going to be at normal crown 2%. And it looks like, based on our diagram, our outside edge of pavement is going to be slightly above 0, and we're going to have to find the triangle, use a triangle to find what the actual value is there. So inside lane, cross slope of 2% because we're past that reverse crown and almost to adverse crown removed. And our outside lane, we're going to use our triangle there. So if we look at the big triangle, it's 6% for our super elevation component and 275 feet. That's our super elevation runoff. And let's set that equal to X over 7.77 feet because we're looking for station 58, and the ST is at station 58 plus 07.77. So solving for X, the cross slope is going to be 0.17%. And our cross slope will look like this. The inside edge of pavement elevation, or inside lane cross slope is 2%. The outside lane cross slope is 0.17%. And that is our final answer for station 58, 2% for the inside lane and 0.17% for the outside lane.